Hi everyone, welcome to our presentation, A Holistic Approach to Building 3D Web Apps. My name is Raluca Nicola. I am a product engineer on the ArCGIS API for JavaScript team, and I focus mainly on the 3D features. And here with me is Russell Roberts. Russ, I'll let you introduce yourself.
Thanks, Raluca. My name is Russ Roberts. I'm a product engineer on the ArCGIS Online team, and I work on both 2D and 3D based projects. For 3D wise, it's like publishing scene layers and updating them. And I'm here to work with Raluca to show you how you can publish your own 3D content to ArCGIS Online or to your enterprise setup and create a 3D web app with the JavaScript API.
All right, so in this presentation, we're going to be showing you how to get your data from wherever you download it or whoever your data provider is, all the way onto the web with a custom app that you can share with the others. And in the first part of this presentation, we're going to talk a bit about theory, like have a small introduction to 3D, talk about web scenes, the different specific 3D layers, and visualization. And then in the second part, we're going to have a hands-on demo where Russ is going to show you how to process the data in ArcGIS Pro and create a web scene. The example we're going to be using is the San Francisco building data. And in the second part, I will be showing you how to take that web scene and build a custom exploration app of the buildings. So with this, I'm going to pass it on to Russ to talk about web scenes and the platform.
For those of you not familiar with 3D across the ArcGIS platform, the slide's a great introduction for you. 3D can be a combination of 2D and 3D content that we're visualizing within the scenes. So like this first bullet says, it could be scene layers and feature layers. For example, your scene layers could be 3D buildings that were originally multi-patch feature layers, and then you could have it combined with a point of interest 2D feature layer, and you could combine these two 3D and 2D layers together and create a rich scene. And within the scene, they're being powered by services. So their scene layers and feature layers are both scene services and feature services. And these aren't just the two different layer types that we support within scenes. It's just a great example to kind of think about how can I bring my 3D content into a scene and combine it with some of my 2D content to create a rich end product. And when you're creating these scenes with this combination of 2D and 3D layers, you can leverage smart mapping to create higher visualizations. We could use a line of sight analysis to kind of get a little bit more information from that scene. And we can share this out across the platform within a web scene that we'll talk about a little bit more in an upcoming slide. And that can be shared across mobile devices through web browsers, and it can be leveraged within desktop applications like Pro. And we're using these web scenes as like a building block. So the settings that we're preserving within this web scene are going to be honored across these clients. So what are web scenes? I kind of covered that a little bit in the previous slide, but it's pretty much exactly like a web map. We have our own web scene specification on the developer site that you can check out if you want to learn a little bit more about it. But it's where we're storing all the customizations that you've made to your 2D and 3D layers. And this could be to your feature layers, map image layers, scene layers, tile layers, WMS, and vector tile layers, and more. And in these scenes, we can control environment settings like shadows and time of day. So like in the image that you see here in the slide, I could set that daylight widget to 6 a.m. and have shadows enabled. So then when other users open up this web scene within a different application, they will see it start with the sun's position at 6 a.m. and they could start doing a visual analysis of where the shadows could be that time of day. We can also have these scenes saved as global or local scenes, and we'll discuss that in an upcoming slide with a little bit more information. And to further talk about web scenes, like how you can actually create these, you could be using the scene viewer in ArcGIS Online, Or if you, let's say, have access to ArcGIS Pro, you could use Pro to publish up these global or local scenes and what settings you have saved within that scene within Pro, and when you share it to Online or Enterprise, and you open it up in the scene viewer or in a different application, will be preserved. And when you're also publishing these layers from these scenes from Pro, to Online or Enterprise, you can also publish your 2D and 3D layers. So everything kind of gets bundled all up at once, and caches get built, feature layers get published, and so on. And so that way, when that scene is ready, you have all those layers ready to be viewed within the applications. And if you're using the ArcGIS JavaScript API, you could be leveraging the webscenes item ID, which is what Raluca is going to be using, to kind of easily and quickly pull in some preserved settings. So that way she doesn't have to do this stuff in code. She can just leverage some of the quick customizations I made within these authoring clients and use it within the application she's building. I kind of talked about global and local very briefly in previous slides, and I find this slide's a great example to help you decide what kind of scene do you want to build. Global supports WebMercator or WGS84 tiled or cached layers. So that's like scene layers, elevation layers, and tile layers, elevation layers, and scene layers, sorry. And it's coming across in the sphere curved service, and it supports underground navigation now as well. Local scenes, on the other hand, only support projected coordinate systems. So this could still be WebMercator, but then it could be other projected coordinate systems that you might have your cached content in, or even your dynamic content. That could be a feature layer, let's say. It's not a curved surface, it's a flat surface. You can clip the extent, like you see in these two scenes, to just your area of interest. And local scenes also support underground navigation. And to talk about how you could generate a scene in code in global or local, here's Raluca.
So let's have a look at how you can create such global or local scenes. Here on this example on the right, I have a globe, a visualization of earthquakes. And to generate this, I need to define a map with a base map. On the base map, I'm setting as a base layer this nice tile layer that John Nelson created. And then as layers, I am loading an earthquake layer. Now, this map could be visualized in 2D by passing it on to a map view, or in 3D by passing it on to a scene view, as I did here. And to change between global and local, the property that you would need to set is viewing mode. Now, if you want to have a global view, global is the default value for the viewing mode, so you wouldn't need to set it. But for a local view, you would need to pass in viewing mode as local. So let's have a look at an example of a local scene. Again, I'm defining the map with a base map and maybe some layers, and then I'm passing it on to a scene view, and this time I have to set viewing mode to local. Additionally, in local scenes, you can also set a clipping area, and this will always be an extent, so that basically what it does is it cuts the data at the borders of the extent you're passing. Some more 3D concepts. An important one is that of a camera. So the camera is basically the viewpoint from where you're looking at the data, and it has a position and then also a tilt and a heading. This is important for every scene view has a camera. If you don't set one, then we will assign one by default. I think looking at 0, 0. As for the navigation, in a scene view, you can navigate manually with the mouse, with the keyboard or the gamepad, or you can also programmatically, you can program navigation with GoTo. This GoTo method is a bit of a magic method because it can take a lot of things. So you can pass in a camera, you can pass in different parameters like you see in the code snippet in the first example. center, zoom, tilt, or heading. You can pass in geometries or, for example, a graphic or extent or an array of graphics, and it will automatically calculate where it needs to zoom. As for the visualization, in 3D, there are multiple, let's say there are two categories of symbols. You can have flat symbols that you probably already know from 2D. They are expressed in screen size units. And yeah, basically the graphics are in screen space. But we also call them flat symbology. And you can also have volumetric symbology. This time, the values are expressed in real-world units, like feet and meter, for example. And the graphics are in real-world space. So basically, as you zoom in and out, they will become smaller or larger. So let's take, for example, the icon symbol 3D layer example. These are basically just icons. They always keep their 10 pixel size or whatever you set them to. Whereas if you set objects like a cone or a cylinder, these will be expressed in meters, their sizes. So as you zoom in and out, they will become smaller or larger. So yeah, for point symbols, you can have different 3D model or 3D objects, we call them. It's called actually an object symbol 3D layer, like cones or cylinders or cubes, or you can even load your own 3D model in there. Then for line symbols, the equivalent for it as a volumetric symbol would be the spat symbol 3D layer, which could look as like a pipe, as a pipe symbol. And then for polygons, you can have the normal 2D polygon with a fill, or you can extrude them, and that will create this extrude symbol 3D layer. And specifically through 3D, there is one more symbol type. We call it a mesh symbol 3D. This is mostly used for 3D objects as like scene layers, 3D object scene layers. And the definition here on the left, you can see it. It's basically a fill symbol 3D layer where you can pass in a color. And the color mix mode specifies how the symbol should deal with the texture. So if it has textures and you set color mix mode to replace, like we do here, then it will completely remove the texture. Otherwise, you also have the options to tint or to multiply the texture. Next, we're going to talk a bit about layers. So we're not going to go through all the layers, but we kind of decided to talk about elevation layers and scene layers because these are kind of the most important for 3D. Let's talk now a bit about some specific 3D layers. So for example, elevation layers are the ones that make up the ground of your scene, and they help to provide vertical geographic context. The way you would create one from your digital elevation model is to transform it to a tile package using blur compression in ArcGIS Pro, and then upload it to the portal for ArcGIS or to ArcGIS Online. Once you have it, you can add it to your application by passing it as a layer, as an elevation layer, in the ground property of the map. In case, though, you don't have your own elevation data, then Esri provides several world elevation services. One of them would be the terrain. So this is elevation data for all the regions that are land on the globe. And then if you need for both land and ocean, then there is the World Topobathymetry service that is made available to you. And these two snippets would show you how to add it to your application. Next, I'm going to pass it on to Russ to talk about scene layers.
To continue our discussion on 3D layers that you could use within your application, let's talk about scene layers. Scene layers, they're cached web layers that are optimizing for large amounts of data. And this data could be 2D and 3D features. And you could use them to view them in an application like the Scene Viewer online, or you could bring it into Pro, let's say. We have 5 different types of scene layers available today. One of them is the point scene layer. That's a great use case for 2D data. It could be, let's say, a large number of trees within your county, and you could still use 3D symbols against these points, but the data itself are 2D based. Next, we have a 3D object scene layer that's coming from multi-patch data that was then published as a scene layer from a scene layer package or from a feature layer. Next, we have an integrated mesh scene layer. This one's normally collected by drone imagery that is stitched together, and it'll be a combination of natural features like trees and then also like man-made features like buildings. And so it stitches them all together into this realistic scene layer. Next, we have a point cloud scene layer that's derived from LiDAR data. And finally, a building scene layer that's coming from Revit data. And let's just talk about those scene layer examples that I have here within this slide. We have a building scene layer here, which is a library that was published from a Revit model in ArcGIS Pro. And if we were using the Building Explorer widget, we could go in and look at this building with a little bit more detail, where we could kind of pull back some of the layers on the outside, like the exterior shell, and look at either the HVAC, the structure, windows, or even the furniture within this building. The next example here is a 3D object scene layer that was published from the multi-patch dataset. This is just a building shell, so it doesn't contain any of the information that we have like in the building scene layer here, like that interior infrastructure. Here we just have the shell of the buildings itself. And finally, this example here is a point cloud scene layer. It was published from a LiDAR dataset, and this is millions of points using the RGB coloring to give it this realistic look. Let's get into the demo portion of our technical session. We've broken this up into 2 parts. The first part I'll be covering, where I'll be creating a web scene from some San Francisco building data. I'm going to cover how I actually kind of enriched some empty buildings with some extra attribute information. And then Raluca will be diving into the second part of this session, where she'll build a custom application using the web scene and hosted data that we'll be publishing. So how do we actually create a web scene? And I'll be using some San Francisco buildings. I'm taking the San Francisco buildings that have already been texturized, so they have a realistic look to them. But there's no attribute information in them, and I'm going to tell you how I actually combined some assessor information with the building year and height, and combining that to some already generated multi-patch features. We're going to be publishing that data with ArcGIS Pro, and then creating a web scene in ArcGIS Online. And how can you actually create these layers in ArcGIS Online and Enterprise? Just as an overview, we won't be covering all of these steps, but I just want to put this out there for some additional information. In this case, we will be creating a scene layer package in ArcGIS Pro. We'll be uploading that package to Online, or in your case, it could be a portal. We will be publishing a scene layer from that scene layer package. And this scene layer package could be used to publish point, 3D object, integrated mesh, or a point cloud scene layer. So we'll just be doing a 3D object scene layer in this case, but I just wanted to cover off that it's not just for the 3D object scene layer. It could be used for these other types as well. We could also choose to share this data directly from Pro to Online or to Portal, and we could publish a scene layer with an associated feature layer. And we could use this to publish a point or 3D object scene layer because they both have a supported associated feature layer, which would just be point geometry or a multi-patch geometry feature layer. So that's why it's restricted to just those 2 options. We don't need to publish a 3D object scene layer with an associated feature for this case, but if we want to leverage any of the, let's say, smarts behind the scene layer, leveraging the feature layer, we would do the associated feature layer case. And then Online also supports publishing a scene layer with an associated feature layer without using Pro at all. So I could have a point feature layer or a multi-patch feature layer already in ArcGIS Online, and I could go to that item and from it directly choose to publish a scene layer. And that way I don't need to use Pro if I didn't have access to it. And it just gives you a nice light web experience as well. And then how do we actually create these web scenes? We can open the scene layers into the scene viewer, and we can add a 2D or 3D layers, and then we just configure our web scene there in the scene viewer. We could also choose to do everything in Pro as well, where we would add that 2D and 3D content. We could configure those layers with like smart mapping, pop-ups, etc. And then we would just choose to share that scene and all the layers to Online or Portal, and everything would just be bundled up with that web scene. And from that web scene, we have an item that is shareable to Raluca for her to use. Here I have multi-patch features already loaded into Pro. They've already been texturized, but when I first was given this data, it was just the building shells themselves. There was no attribute information like year built or height or land use. And I wanted to be able to get some of that information attached to these buildings so that way we could create a richer application. The reason why they kind of lost that information is because when you are building your features from, let's say, extruded polygons, you'd be running the Layer 3D to Feature Class tool. And when you're doing this, you can do a group field, and this is what you are using to merge multiple input features into one. And when that takes place, you're kind of simplifying down the attribute table to just that one group by field. So I wanted to take some additional information that I found on the open data site that San Francisco provides that contains some assessor information that had the year built, height, and land use. So to kind of join the two of them together, I had to do a couple steps. The first thing I did, I ran the multi-patch footprint tool, and this just generated some footprints, polygon footprints from all those multi-patch features that we had. The next thing I did, I brought in the tabular data from the open data site and just displayed it as XYs. Then I was able to do a simple spatial join is what I wanted to use in this case. And when I did the spatial join, I was able to join the points with the polygons. And because these polygons had a unique ID, building ID, I was able to join them back to the actual textured buildings. So if I just re-enable the buildings, they will load in, and I'll show you the attribute information that we have. Now that we have them loaded in, let's just look at the pop-up, and we can see, here's the land use, the year built, and the height. Now I can actually get this content to online, to my enterprise, multiple ways. The first way, the most simplistic way, let's say, is first I might just want to create a local scene layer package because I might want to view it in Earth, or I might want to bring that scene layer package back into Pro and see what it looks like. So then I can just run the Create 3D Object Scene Layer Package tool, and this will take that multi-patch data and generate that scene layer package of 3D object features. The 3D object scene layer package is only used on multi-patch features, so it's a very specific feature geometry for this tool. I could also just right-click on this layer and go to Sharing and share it as a web layer. And here's where I can set up the configuration to either cook it as a local scene layer package first, then upload it to online or my enterprise, or to go ahead and publish this as a scene layer with an associated feature layer. I can do this just by going to the configuration, and I can say I want to cache this online, which is using that scene layer with associated feature layer, or I could cache this locally, which would first create a scene layer package and then upload it to online to begin the publishing process for me right away when it's completed. The final way I could actually share this up is as a completed web scene. And this will give me the option to publish up a web scene first, set up the sharing, and then I can go into the content. I can see what is being generated here. I can remove the layers I want. But in the case of the building scene layers, we can see we might only want to have those building scene layers to be generated online with the associated one, or I can do the same thing where I can switch it to cache locally. In this case, I'm going to share up a web scene with the layer cached locally, and it will create a web scene with a scene layer published from a scene layer package. Add some great metadata, and then I'll click Share to begin the publishing process. Here we have the completed web scene and scene layer that we published from Pro. If we go and look at that scene layer, we'll see that was published from a scene layer package. And this was the one that we kind of cooked locally, and then once the cache generation finished, it began uploading it to ArcGIS Online, and then that kicks off that publishing process right away. And then we can go to this web scene, and we would see the completed buildings already here, and we could click on them and get a little bit of information like the year it was built, the land use, and the height. This is all stuff that Relucode could use. We could even go into it and we could style these buildings ourselves. Let's say if we wanted to style it by year built, we would be using counts and amounts, and I could adjust the slider and we could see this information update in real time. Change the colors if we wanted to, and we could say enable edges, and we have some really sharp looking buildings. Now let's just look at some of the tools available here in the scene viewer. We could use the search widget to use locators that have been configured with our organization, but we could also configure a feature search on features within a scene. So I could look for a certain name of a building and use feature search to locate that building for us. Then we have the legend and layer list control, the base map switcher, where we can pick our different base maps if we wanted to, from like dark gray, light gray, anything that you've already had configured within your organization. And we could set up, if we had subsurface data, we might want to play around with the ground transparency here. Or we might not want to use a base map at all. Next is the daylight widget. This is what you saw us kind of talk about earlier in our presentation, where we could kind of set it up, just open the scene at 8 a.m., and this is where the shadows positions would be at this time of year. We could even choose to play it through all the different months of the year, or by the hours of the day. We also have some additional tools like measure length, measure area, and we have a slice tool as well that lets us kind of slice against planes. And when we choose a plane that we might want to slice, it'll reveal the content that could be within it or below it. And we could choose what layers to exclude. So we might want to exclude the buildings, but we're still removing, the base map and any other layers that would exist within the scene. Finally, we have the share widget, where we can give a link to the scene or create a web app and play with any settings like the performance. So here I want to see the best quality of our 3D features, and I'm just using the default navigation. Once I have the scene finished and configured for Relucode to use, all I need to do is click Save, and my changes are stored within that web scene itself in JSON, and I can just give her the web scene ID, and she can begin the development process against the scene.
So in the second part of the demo, we're going to be looking at how to build a custom exploration app using the web scene that was created. First of all, I want to show you the app live. So basically, I loaded the web scene and I added a few features, like, for example, this TimeSlider that if I let it run now, it will filter through the buildings based on the construction year. You can also see that the charts here are updating as the buildings are added to the view. Another thing that you can do with this app is to draw a polygon, for example, and then it will filter out all the buildings whose extent is not intersecting the polygon that I just drew. So important to know is that this spatial relationship is done, or the intersection, for example, or contains or disjoint is done based on the extent of the building and not the footprint. And in this case, I'm setting the spatial relationship to intersects. So as soon as it will intersect the extent, the building is being displayed. Now, another thing I could do is, for example, to move this polygon around, or I could say, oh, actually, I want to cover this whole area, so I could just go ahead and move the vertices. And the charts here are updating as I am changing it. Now, another thing I could do is set renderers as shown here in the graphics. So this I find a really nice way. Instead of adding a legend, I already have this graph that shows some information about my layer, and I can use the renderer to basically build my graph is a legend of the layer and the renderer that is used to be displayed with. All right, so in this session, we're not going to build this whole app from scratch, but I will be showing you how to, like, what are the main features that help build this app, and I'm going to be showing you how to use them. An important thing is that if you want to browse the app by yourself, you can find it at this link, or if you want to look at the code, then you can just go to my GitHub page and you'll find the code there. So let's look a bit at the features that I am using for this app. First of all, I am loading the web scene in a custom app, and we're going to be looking into that. Then the default pop-ups for layers are usually, you probably know this table, so we're going to want to customize that using the API. I'm going to be adding the TimeSlider widget, which is an API widget to filter the buildings by their construction year. And then we're going to draw a geometry using the sketch view model also to filter the buildings. Last but not least, we're going to be querying for statistics the selected buildings, and we're going to display the statistics in a chart. So just to go quickly through the features before I jump into the demo, to load a web scene from ArCGIS Online or a custom portal, you need to pass in the portal URL, and then when you instantiate the web scene, you need to pass the portal item ID. To customize a pop-up, you need to set the pop-up template on the scene layer. And in my case, I'm just setting a sentence where I'm adding in values from different fields like the height or the year, the build year, or the land use. Next, adding a TimeSlider widget is done just as with most other widget. You define it and then you add it to the view UI. In my case here, I'm adding it to a container that I already have, like this is a div element in my scene. And some options you can set are the mode that you want the TimeSlider to operate in. So cumulative from start basically means that it will display all the features that are between the start point of the TimeSlider and the point where the thumb is. You could also make it work in time window mode. So basically you kind of have a time window, as the name says it, or for example, cumulative from end. But in this case, this is how it works best. Then you specify the time extent, the full time extent for the slider, the value where the thumb should be at when the app starts, and the stops are mainly for setting the time interval between which the thumb should move. So for example, when you play, it will move every 5 years. Now, if you pass on the view to this TimeSlider, then it will detect automatically all the layers that have a time info, and it will filter them. But in our case, scene layers don't have time info. So how you can make this work with scene layers is to watch for the time extent and then pass in a definition expression that will filter the layer based on that time extent. And in our case, because we have this cumulative from view mode, we're really only interested in the end time, and we're going to filter out all the buildings that don't satisfy this condition that the build year is smaller or equal to this time extent end period from which we extract the year. All right, next we're going to be looking, I don't have a code snippet for this, but we're going to be looking into the code with the demo at how to draw a selection polygon and then filter out all the buildings that are not intersecting this polygon. All right, so last but not least, we're going to be looking into client-side queries, and what we're going to do is to query the features that we selected using our polygon and to display the number of display the statistics in a bar chart. In this case, it's going to be number of buildings by height. I'm only building one chart in the demo because the other ones are pretty similar, so we don't need to look into all of them. All right, so let's get started. I made a super simple setup here. I have an index.html file and the JS file with all the JavaScript code. Basically, all the code is now commented out, and I'm going to be remove the comments feature by feature. So first of all, let's look into loading the web scene part. As I showed you also before, I'm defining my portal URL and then loading the web scene based on the item ID. Now if I refresh this, we should be seeing here the web scene from Russ. Feature slowly loading in. Next thing that we want to do is to change these default pop-ups that you see here. So it's basically a table with all the attributes, and we want to change it to something more friendly, just one sentence where that tells the user what is the height, what is the land use, and when was it built. So in order to do that, we want to go through all the layers of the web scene and retrieve the one that is actually the scene layer with the title of San Francisco buildings. Next thing, this we don't need for now. Oh no, we do need it. This one we don't need for now. And then also these lines. So the next thing that we're going to do is to set up the pop-up template as I showed you with the new content. And we should be now having custom pop-ups. So now clicking on the same building, you can see this phrase showing up. Next thing that we want to do is to add the time slider. So basically I made a function here that adds the time slider widget. I'm instantiating it. I'm passing in the container. So this time I have this div element here with an ID of time container, and I'm passing it on to the TimeSlider container property. And this div at its turn has the stylings with the positioning and so on in the CSS. Next, I am setting the mode, cumulative from start, as I explained before in the slides, full time extent value stops. And finally, I am setting a watcher on the time extent to filter the layer based on this time extent. And now when we load it, we see the time slider. Start time is, start year would be 1900 and end would be 2020. And I can let it play, or I can just move it around faster and it will filter my buildings. All right, next step would be to actually start drawing the polygon. So in order to do that, we're going to be adding a new layer. I'm going to call it sketch layer because this is a graphics layer that we will draw on. The mode is on the ground because I want my polygon to be on the ground and not snap to the buildings or anything. I'm really using basically a 2D polygon as a filter. Then I'm instantiating the sketch view model, passing in the sketch layer and the view. And I'm setting up 2 event listeners, create and update, so that when the user finishes creating the graphic, then I will filter by that graphic. Later on, we will also do the statistics, but for now I'm commenting that out. The same thing happens on update. I'm going to be filtering by the graphic created when the sketch view model updates. And the meat of the function is of the feature is this filter function that basically sets a filter on the building layer view. As I said, these are all client-side filters. Spatial relationship is contains, could be intersect, or could be disjoint. One thing we didn't do so far is to actually set the building layer view once it's created. And this is what we do with this line of code. So we're waiting for the layer view to resolve, the layer view of the building layer. And once it does that, we're passing it into this semi-global, so this variable that is accessible from everywhere in our application. And yeah, basically then we're setting this filter on it with the geometry that we pass with the filter function. To access this though, we're going to be needing a button that tells the user that the user needs to press in order for the sketch view model to enter this creation mode. And I'm also going to need to uncomment this button here. We have a draw polygon button and a clear selection one. Let's look into the clear selection later on. Let's make sure that this works for now. So here are my buttons showing up. And once I have everything kind of loaded, I can click on draw selection, and then I'm starting to draw this polygon that then filters out everything that is not contained in my polygon. I could choose to like extend it over here, and then it automatically updates. All right, now if I want to remove this filter, I would need to implement the clear selection button. So the event listener that I'm adding on clear selection does a bunch of things. First of all, it cancels whatever operation the sketch view model is in. It sets a null filter on the building layer view. It removes all the graphics from the sketch layer. And it also, here, we will initialize the data, like update the data on the chart. But for now, we don't need to worry about that. So I'm just going to comment it out. Yeah, this should now clear my selection. So let's draw a polygon again. One other thing is, like, if I use the TimeSlider now, then it will start filtering only on the selected features. And now if I do clear selection, then it will remove the spatial filter. All right. Next thing on would be to actually query for the buildings. So we're going to be doing that using this query stats method. So let me comment that out. And this will be called every time the user creates a polygon, finishes creating a polygon, or updates it. And the query stat methods is over here. Basically, the statistics are passed on to the query, but we need to define them. And to do that, I have this array of statistics here. This is where I'm actually grouping the buildings by the height. So the SQL query returns a 1 every time the building the feature has a height between 0 and 20 in this case, or a 0 otherwise. And what we're doing is to sum this up, and then we're getting the result in a field called height 020. And this happens for all these categories that I'm defining. So yeah, I'm building the query using building layer view create query. It's important to use this method because I might have set already, actually I definitely set already this geometry as a filter on the layer view. So create query will keep track of that. Otherwise you will get results for like all the buildings in the layer view. Then we're passing on the out statistics that we defined over here, and we call the query features method on the building layer view. And then we would update the charts, but for now, let's just check the result in the console just to see what it looks like. All right, let's see if this works. So I'm going to be drawing my polygon again. And as you can see, I'm getting this result here that has a features property, and these attributes are the ones that I defined. Made it a bit bigger, that I defined in my out statistics array over here. So height 020 is 0. Oh, everything is 0. I'm running into this every time because I actually have to set the out fields so that the attributes are actually downloaded when I make the query. So let's try this again. Okay, I'm drawing a selection polygon, and now I should get some results that are not 0. All right, there we go. So these are basically the properties that we're going to be passing on to our bar chart. And to do this, we need first to create the chart. So this one I'll be commenting and create height chart. I'm using chart.js. You can use any library you want. Yeah, just whatever it's easier for you. And I'm not going to be going into details with this code because this is really specific on your charting library. First, I'm passing in the data is 0 every time I don't have a selection. And then once I have a selection, there was already this method here where I'm basically, sorry, where was it? Over here, where I'm basically updating the charts, the chart using that result. And the update chart method is over here. So I'm just passing on the data that I'm retrieving from this query features method into the chart, updating it, and I will also be clearing it as soon as I remove the selection. All right, let's see how this works. Oh, sure. I'm running into all the possible issues now. So the chart needs a canvas to render in, and I have not commented this out. So now I'm getting the chart. It doesn't have any data in it, or better said, it has 0, 0, 0. And as soon as I'll be drawing a polygon, it should update with the data that I'm retrieving from the features query. And then if I move this around, then it will update. And then if I clear the selection, then everything goes back to 0. One last small thing that I want to show you is how to apply a renderer. So I'm having this button here, apply height renderer, and this is basically just the same as you would do in 2D. We have our building layer and we're just setting a simple render on it with the color visual variable. One cool thing that I wanted to show you is this extension for VS Code that Kelly and I worked on. And what this does is it has some code snippets that you can use to not type so much. So it's super useful. Basically here I can pass in a mesh 3D symbol, and I'm going to leave the color as it is because actually for this rendering it doesn't really matter. And then I'm going to pass in the visual variables. So here I'm going to have a color var. The field property that I want to drive the visual variable by is the height. Here I actually don't have this. I also don't need this, the legend, I don't really need it. Oops. All right, and then I'm setting it like the values would be between 10 and 60 meters. And here, let's say I'm doing this white and then this one purple. The label would be for the legend. You saw how I solved the legend problem by driving the colors on the chart. So you could also do that, or you could just load in the legend. So yeah, basically this is it. Now if I load this and I would apply the height renderer, you're going to see how it actually colors the texture. So I think the default is multiply. And sometimes you might want this, sometimes you might not. So then it's when we're going, this is a good use case for the color mix mode property. In this case, I don't want this. I want to see just the color and remove the texture. So I'm setting this color mix mode property to replace. And now if I apply the height renderer, then it will completely remove the texture. All right, this was the demo. Don't forget to, if you have any questions, ping me or Ross on Twitter, or just ask your questions on GeoNet, and we'll make sure to answer them. Thank you very much.